Yo, hey guys. So in this one, I'm going to talk about completing the square, which is a very common thing in math that a lot of students need to know. Basically, in completing the square, before we try to understand what it is, let's just firstly talk about like what it means by what we mean by squares. And obviously, yeah, we're just talking about like an actual square, where it's like 1 by 1 is 1 squared, 2 by 2 is 2 squared, obviously like these sort of squares. But in the context of algebra, you may have come across things like x plus 1 squared. This is what a perfect square is. Yeah, like x plus 2 squared. It's another perfect square. And the thing about these squares is if you expand them out, which hopefully you can do by now, we will notice a pattern. So if we expand these out, we have this sort of pattern where, let's grab this guy, the coefficient of x, the second term in the middle, just the way that this square will multiply itself out, half of this number, which is 1, and that squared is the number that we're attaching on. You'll find that this pattern recurs through every perfect square, right? So if you look at 4, half of 4 is 2, and if you square that number, you will get 4. Same thing with 6. If you halve 6, it's 3, and if you square it, you get 9. So if you see that sort of pattern happening, then you've got yourself a perfect square. There's a really nice visual representation that Eddie Wu gave, so maybe I'll link that in the description. But in this video, I'm just going to focus more on how to actually just complete the square when you're given it as a question. Okay, so first of all, we might get something like this. The question will maybe be like, all right, we got x squared plus 12x. Okay, and the question is to complete the square. We're going to take the same idea that we did in these guys and look at the coefficient of your x, which is 12, right? We're going to half that number and then square it on. So half of 12 is 6, and we're going to add the square of that on. Now, since the question just gave us this, x squared plus 12x, if I want to add 6 squared to this guy, we're going to have to subtract 6 squared as well, just to make sure that we're not actually changing anything, right? Obviously, 6 squared minus 6 squared will be nothing, and you'll go back to the question. Okay, but we want to write it like this because this part here will create a perfect square. Like this. Okay, so when someone says to complete the square, they're looking for this type of perfect square. Okay, now what does that look like in an equation? So in an equation, if the question says like solve by completing the square, and they give you something like x squared plus 6x equals to 91. Okay, so if we're going to try to solve this question, let's look at the coefficient of x again, which in this case is 6. If you half that number, it's 3, and we're going to add that on, right? So x squared plus 6x plus 3 squared. And let's add 3 squared to the other side as well. For the same reason like we did in the last question over here, we don't want to change anything, right? We want to make sure the question remains the same. So if I want to add 3 squared here, we should add 3 squared to the other side as well. Which is convenient because on the left-hand side, now we've got a perfect square. We get 91 plus 9, which is 100. And from here, we can just solve the equation. Okay, so it looks like both of these are the square numbers, right? So we can square root both sides. I can say x plus 3 is equal to plus minus 10. Okay, hopefully you followed along for that. And now we just have one more step to answer the question. We can say x equals to, first of all, I'll just write x plus 3 is equal to 10, x plus 3 is equal to negative 10. Okay, that's what the plus minus means. So x equals to 7 and x equals to minus 13. These are the solutions. Okay, so that's how you complete the square. The one last thing I'm going to show you is you may have a question like this. This is the last type of question you might have to do, which is 2x squared plus 8x minus 1. The only caveat with completing the square is the coefficient of x squared, so the one at the very beginning, needs to be 1. It needs to be monic. So in this case, it's got a 2 in front of it, which makes it a little bit more complicated in terms of completing the square. Okay, so what we're going to do is we're going to divide everything by 2. Let's say x squared plus 4x minus a half. Okay, and then once we've divided everything by 2 and then made the coefficient here just 1, now we can do the same completing the square that we did in the previous question. Okay, so firstly, before I do anything, I'm just going to move half to the left, to the right hand side. And let's complete the square. So half of 4, and if you square it, it's going to be 4, and let's add 4 to the other side as well. So on the left, we have a perfect square, and this, let's say 9 on 2. X plus 2 is equal to plus minus the square root of 9 on 2, which is the plus minus of 3 on root 2. And x equals to plus minus 3 on root 2 minus 2. And I'm just going to leave the answer like that. You may want to go ahead and rationalize this denominator if necessary, but yeah, the main thing I wanted to illustrate was this completing the square idea when there's a coefficient at the very beginning. Okay, make sure to always reduce it down to 1 before you complete the square. Okay, and then we're going to use this idea to actually prove something that you guys use all the time, the quadratic formula, in the next video. Alright, thanks for watching. I'll catch you guys in the next one.